Welcome to the Scientific Notation, SI Units and Conversions lesson. All right, let's get down to it. So, with scientific notation, what are we trying to do? Okay, so scientific notation, right? So, as scientists, we have come up with a specific way of writing very big or rather very small numbers using the decimal system. And how does the decimal system work? Okay, so the format of scientific notation is very specific. All right, so you need to write unit digits, okay, one or two decimal places, then multiply by 10 to the exponent. Okay, so you need to make sure that your value has, usually we prefer two decimal, okay, a unit, 1 unit, okay, two decimals multiplied by 10 to a certain exponent. Okay, for example, as you can see here, you can see 3.45 times 10 to the exponent of 5, or for example 7.2 times 10 to the exponent of minus 12. All right, so we always try and make sure we write we write our number as, for example, a specific number, maybe a specific number a times 10 to the exponent a specific number. Okay, okay, so we try and make sure that we write a specific number. I'll write again an a, maybe times 10 to the exponent, and so we try and write it in that format. Okay, so that's scientific notation, and we make sure that our number a has at least 1 unit and two decimals. Okay, so let's look at rounding off in scientific notation. All right, rounding off numbers. So yeah, let's go rounding off numbers. Okay, so let's say for a number like this one, if you round it off to two decimals, all right, we all know that uh, if you are, for example, looking at numbers from 0 all the way to 10, right, you know that halfway is 5. Okay, so which means if a number is at least halfway and going upward, then you round up. If a number is below halfway, right, then you round down. So like I said, halfway, so halfway, so halfway, right, is the number 5. So now the issue is the number halfway and up, or is the number less than halfway? Less than halfway means, so which means if a number is less than 5, you round down. Okay, and if a number is greater or equal to 5, round up. Okay, show you what I mean by that. So let's look at the number that we have there. Okay, so you have 2.4.65252272. There's lots of decimals, But then with scientific notation, we prefer that, okay, count to 2 decimal places, right? Which means if you count to 2 decimal places, right? So we already have, there is our decimal, then decimal point, that's a decimal point. So the two numbers are, okay, that's 65. Right, now we will consider the third number to see, okay, should we round off 2.65? Should it remain the same, or should we round up? Okay, should we round it off to 66? Okay, then, right, so you can see there we made a split, so you can see the number there. Okay, so in this case, I know the number looks a little bit different to that one. That one has a 2 again, so but anyway, just showing how to round off. So let's say maybe you have this number. Okay, so you have a number 5 there. So now it means that since you have a number that is, for example, from 5 and above, you can round up. So round up, right? Okay, so you round up, and then it will become a maybe 2.66. Okay, so the aim is, after 2 decimals, you can make a split and see the number that you're supposed to consider. Okay, and then therefore, okay, no, it's not 66, 63, sorry. So that would be 2.63. Okay, so which is, yeah, then that would be your rounding off. Okay. Okay, so then you're rounding off. Okay, then how do we work with big and small numbers in scientific notation? Okay, so basically, let's look at it. If you've got a very big number like this, okay, so you can see the decimal point there, okay. You can see that there's a decimal point there. So the aim now is to try and shift the decimal point, okay. So this is how it's going to work. So that's going to be 6.2 times 10 to the exponent 23. All right. Why is that? Okay, because if you were to get to the to count, okay, up until the first digit, okay, you'll have to go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and then 23. So we will put our decimal point right there. Okay, so then after putting a decimal point, so you can see there now where the decimal point is between 6 and 2. And then since it's all zeros, that's why we are putting 6.2, but normally it's supposed to be 6.2, 6.20. So you're supposed to have a 0 there. Okay, it's supposed to be 6.20 times 10 to the exponent 23. How did we get 23? There are a number of times that we shifted the decimals. Okay, counting the how many times we are shifting the decimal number by number. So that is the number that we put as an exponent. Okay, so you can see counting all of that, okay, all of that until we got to 23 there between 6 and 2. All right, so that's how we write scientific notation for very large number. We simply shift the decimal to the right, to the left, and we count how many times did we shift the decimal point to the left. That's going to become our exponent on the number 10. Okay, now what if we have a very small number like 0.00000912? So this process applies a little bit similar. So we will, that is the decimal point, so we will shift it until we get to in front of the first number. That's the ideal thing, right? You want to have a non-zero digit on 190 digit on your left. Okay, so you will shift the decimal like 1, 2, 3, 4, 5, 6, 7, 8, 9. So once you get in front of the first non-zero digit, then you will put your decimal point. Okay, so which means now you have, how many times did you shift the decimal? Now that's where all comes together. Okay, so you shifted the decimal uh, about 9 times to the right. So if you shift the decimal to the right, then the exponent must be a negative, as you can see there. So you write the number 9.12, okay, this number, okay, round it off to the two decimal. So since there's no more numbers, so there's no need for rounding in this case. So it will just be 9.12 times 10 to the negative 9, right? Which means we shifted the decimal point 9 times to the right. Okay, so then okay, then let's move on. Okay, so now let's say you've got a speed of light like that. It's a very large number. How do you end up how do you end up putting that as a scientific notation? Okay, all right, so you can see that you are going to move that decimal 8 places to the left. Okay, moving to the left means positive exponent. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Then that's where we're going to put our decimal between 2 and the 9. Okay, so and then there we go. Right, so you can see your decimal point there has been shifted, and then right now you round off. So you can see we considered the 2, so we had to make a split there and say this, we have 99, okay, 2.99. All right, so and we have a number 7 on the other side. So since it's bigger than 5, so we're going to round off 2.99, and we obviously from 299 you go to 300. Okay, so it would then be 3.00 times 10 to the exponent 8. There we go. All right, so let's say, for example, what if you have the mass of an electron, which is basically like that, okay? Okay, so then how do you end up, so you're going to count how many decimal it is, shift the decimal until it's in front of the first number. So if you shift it, you will see that you have moved that decimal 31 places to the right. And when you shift a decimal to the right, it means you're going to have a negative exponent for the number of places you have shifted it. Right, so it will look like something like that, where you have 9.11. Since there is no, after the first two decimal, there's no more number, so it will just stay like that. All right. So it will be 9.11 times 10 to the exponent negative, right, to the exponent negative exponent negative 31. Okay. Then let's look at numbers like this. Okay. So, right. So you can, if you look at that, you will take that and you will write them in scientific notation, right? So that would be your work activity. So you write them in scientific notation. Okay. Okay, so you write them in scientific notation. So that would have been the first one, right? That would have been the answer. So you will do the rest, right? And we'll post the memo on that. So the aim is write a number, one unit number on the left side of the decimal point, two decimals on the right side, times 10 to the exponent, a certain exponent, and then uh, depending on how many times you shift the decimal and which side you shift the decimal. If you shift the decimal to the left, positive exponent; decimal to the right, negative exponent. All right. So let's move forward. Okay. So moving the decimal in scientific notation. Okay, so there we go. Okay, you got 2000, right? So it's the same as like 2 times 1000. You got three zeros. Okay, so you treat that number as though it's, okay, you treat it, so you come and put your decimal in the end there, okay, because it doesn't have a decimal, and then you will say 1, 2, 3. So you shifted the decimal to the right. So now that the decimal is there, so you'll end up with 2, okay, times 10 to the exponent 3, because you shifted the decimal 3 places to the left. Okay, it's 3 places to the left and left. Okay, so you must get acquainted that left shift equals to positive exponent. Right, and then if you have a right shift or a shift to the right, okay, it means you're going to get negative exponent, exponent of 10. Okay, so for the other one, for the left shift, you're going to get something like 10 to the exponent a specific certain positive, so I'll just put x, and then for the right shift, you're going to get 10 to the negative exponent a specific number. Okay, so basically if you get something like that, that's what it means. Okay, you end up, so for example here it's 0, so then you'll say 0. Okay, then you shift it 2 times, then the third time, then you are in front of the first non-zero number. Then okay, you shifted to the which side? To the right. So the right shift, how many times? 3 times. Okay, you write the number, there is the number 4, right? Since there are no other numbers in front of the 4, there's no need for us to do rounding off or doing any decimal point. So you write the number 4 times 10 to the negative 3. Right shift means negative exponent. Okay. So a positive exponent tells us the number is larger than 1. A negative exponent tells us that the number is smaller than 1. So, okay, so that's the case. All right, so you remember your maths exponential laws, that when you have an exponent, it means that it's 1 over that number. Obviously, if the number x, it means that the number x is greater than 1. It means that the whole expression is going to be a fraction that is smaller than 1. Okay. All right. So when I move, okay. So you can see some of the answers there, how you write your scientific notation. Very simple. Okay, very simple thing. Okay, it's a very simple thing. Looks like that. Okay, so you can see various numbers. Okay, so others, because you can see the this one had no decimal. Okay, so I mean this one has no decimal, so you put a decimal at the end, okay, of the number, and then start shifting it until you are only left with one non-zero number on the left. So it's 1, 2, 3, 4, 5, 6. So I shifted to the left and I shifted 6 times. It means I have a positive exponent, right? So, and then after I've shifted, the decimal is between 6 and 4. So I'm going to consider the number, okay, the number. So let me do this. I've shifted 6 times. Okay, so in that case the decimal is now here. Okay, so if I check, if I had, the decimal would have been there in front. So if I count the numbers between the the decimals before shifting, the decimal after shifting should be there. So the numbers in between are 6. So there's been a shift to that side. 6 times means positive exponent. Then I'm gonna split between 3 and 6 because 3 is the second decimal. 6 is bigger than 5, so we're going to increase the 3 on the left to 4, and then we ended up at 6.44 times 10 to the 6. So that's how we write our scientific notation. Okay, so you can see how we do it. Okay, so what about unit conversions? Okay, with unit conversions, we need to know our conversion prefixes. For example, giga means it means a million. Okay, it's a billion. Okay, giga is a billion, and a billion is represented by 10 to the 9. As you can see, for example, if you to write it as 10 to the exponent, you will count, okay, how many zeros are there? There are 9 of them, so it is equivalent to 10 to the 9. Okay, then you've got mega, which is equivalent to 10 to the 6th. Then you've got kilo, right? Kilo means 1,000 and is equivalent to 10 to the 3. All right, in a test, you will be given the conversion units, all right, but not all the time. So we will be giving you for now, but in the final exam, you need to know them by yourself. Okay, got hecto, which means 100, equivalent to 10 to the 2, and then so on. You've got the deca, which means 10, and it means 10 to the exponent of 1. Okay, and then what is then 1 is the same as 10 to the exponent of 0. Remember, 1 can be written as any number to the exponent of 0. In this case of conversion, it's 10 to the exponent of 0. Okay, then you got 0.1, right? So if you check, if you to shift this, you'll shift this 1 time to the right, and then you get 1 times 10 is 10, and then the exponent is a minus 1. So you shifted once to the right means negative. Okay, there we go. So centi means 10 to the minus 2, milli means 10 to the minus 3, and then micro means 10 to the minus 6. Right, and so nano, please take note of the symbols so that you can recognize them. Nano means 10 to the minus 9, and pico means 10 to the minus 12. So you need to learn all this by head. It needs to stick into your head. Okay, so let's look at some conversions. Okay, if you could want to convert megawatts into watts, okay, MW to W. So what you should notice is which one is the main unit. Okay, so you've got, so on the left, okay, on the left you'll always have the prefix, okay, so which represent one of those, so which means that M is for mega, okay, so capital M, and on the other side the other W does not have a prefix. Okay, that's what you should take note of there. The other W does not have a prefix, so it means that there is no prefix there. Right, so it means that the prefix is, there's none, so the conversion unit is basically a 1, which means 10 to the 0. Okay, so it's a 1. So now what's going to happen is to convert to the desired units, right? You must take the given value, then that given value you are going to multiply it by the given unit factor divided by the desired unit factor. Okay, so what do we mean by that? Okay, so if you got 6 megawatts, to want to convert to watts, right, you will then say, okay, that's 6 given value, all right, so there's the given value. You're going to say 6 into, okay, mega means 10 to the exponent of 6, so you multiply by 10 to the exponent of 6, and then though you divide by, okay, 1 is the same as 10 to the exponent of 0, so you divide by 10 to the exponent of 0 there, and you are going to get your answer as 6 million watts. Okay, that's how to do your conversion. And then if, for example, if you got 17 millimeters, you want to convert to meters, you can see on the left side of the other M, on the left side you always have the prefix which stands for conversion unit. So milli, if you go back to that those conversion units, you know that milli stands for 10 to the minus 3. Okay, on the other side, okay, the other M does not have a conversion unit, so it means that it's a 1. Okay, so and a 1 represents 10 to the exponent of 0. Therefore, this is how you're going to convert. So it's very simple to convert from one unit to another. Okay, so you want to convert to from millimeters to meters. So it's 17, the given value. Right, it's 17 millimeters, so the given unit factor is milli, and milli means 10 to the minus 3, so you put that in there, and then you divide by 10 to the 0 because the other one does not have a unit prefix. Okay, that should give you 17 times 10 to the negative 3 meters. And you can see the number is written in scientific notation. There's no need for decimals at this point. Okay, if you do write it if you do write that in a decimal form, you could write it as 1.7 times 10 to the exponent negative 4 meters. Right, and the 6,000 W there, watts, can be written as 6 times 10 to the exponent of 6 watts. So that's what we need you to learn in converting units. Okay, so when it comes to scientific notation and unit conversion, that is it. So this will be your work for the day. So it will be posted as well, or as well you can just pause the video and do this work. Okay, so make sure you finish all of it. The memo will be posted. All right, so this will be the end of the lesson. Do make sure you complete this work and we will mark it. Actually, I will post the memo during yeah, maybe I will post the memo in the afternoon, right, when you are done.